In this short lesson, we're going to talk about load factor, what it is, why it matters for drone pilots, how it can lead to a stall, and how to read a load factor chart to answer a real test-style question. Let's start simple. Load factor is the amount of lift your drone is producing compared to its weight. In straight and level, unaccelerated flight, lift equals weight. That's a load factor of 1g. When you turn, pull back, or maneuver aggressively, the drone has to produce more lift to support the turn. More lift than weight means a load factor greater than 1g. So why do we care? Two big reasons for Part 107 pilots. Structural stress. Higher load factor puts more stress on the drone's frame, motors, and props. Stall risk. As load factor goes up, the stall speed goes up too. Even if your drone is small and mostly automated, as the remote pilot in command, you are responsible for understanding these limits. Now, let's connect this to stalls. A stall is not when the engine quits. A stall happens when the wing or rotor blades exceed the critical angle of attack and can't produce enough lift anymore. At higher load factors, the drone reaches that critical angle of attack at a higher airspeed. That means the faster you turn or pull, the higher your stall speed becomes. To visualize this, we use a load factor chart. On this chart, the bottom axis is bank angle. The side axis is load factor in Gs. As bank angle increases, the line curves upward, showing that the drone is supporting more Gs in steeper turns. Now let's walk through a practice question using the load factor chart. This time, we'll calculate how much extra weight, or G-force, is placed on the drone during a banked turn. Let's break this down step by step. Start at 45 degrees on the bottom axis of the load factor chart. Move straight up until you reach the curve. Then move horizontally to the left to read the load factor. At a 45-degree bank, the load factor is approximately 1.4 G. Load factor tells us how many times the normal weight the drone is experiencing. Your total aircraft weight is 7 pounds into 1.414 G is equal to 9.898 pounds. So in a 45-degree bank, the drone is now carrying the equivalent of 9.898 pounds, even though it physically weighs only 7. That's almost 3 extra pounds of force on the motors, props, and frame, just from banking. This is why understanding load factor is so important. More bank is equal to more Gs. More Gs is equal to more stress on the drone. Even small drones can feel big increases in load during aggressive maneuvers. Knowing how to read the load factor chart helps you predict stress on your aircraft and fly safer. In real operations, and on the Part 107 test, this knowledge makes you a better remote pilot in command.